I am Arundhati Bhattacharya from NTPC. I belong to power industry, so I thought that power scenario India, I will cover something. But before that, Mr. Murugan, Director General of CPRI, he has given a very good, opportunity, and future also he has covered. But still, I would, since I have brought it, so I would cover that one. Then India as a power sector, what was our scenario since 1947? This is the graph. Now we know that growth of power sector is the key for our any economic development. And from this graph, you can see that how our power industry has grown over the time. In fact, 2003 Electricity Act, that kick-started the reforms. And then here it was reforms in generation, transmission, and distribution sector, establishment of your regulatory commission at state level and central level, facilities involving a private sector, it facilitates, competitive-based bidding for ultra-mega power projects, and incentives on timely completion of the project. 11th plan and successive plans in generation improved a lot after 2003 Electricity Act. In 11th plan, the target was 78,700 megawatt, though we achieved actually 52,063 megawatt. Next, 12th plan, where we are now at present, the target is 88,537 megawatt. In fact, 2013-2014, the target is made at 18,432 megawatt has been considered. Out of that, 15,234 megawatt is thermal, 1,190 megawatt of hydro, and 2,000 megawatt of nuclear power plant. And today's power generation capacity, what he has already covered, the 133 megawatt as of 31st May 2013. Even after that, still in our country, that there is a gap. It is 5.7% energy shortfall, and peak shortage of your power is 6%. So from this diagram, it is very clear that huge business potential is available in the power industry. Since I belong to NTPC, I just covered 2-3 slides about NTPC. Our present installed capacity is 41,184 megawatt, more than 30 years of operational experience. Capacity of 20,000 megawatt is under construction, which covers 1499 megawatt of hydro and some renewable energy of solar and small hydro is also under construction. And near future also, we are going for full-scale renewable energy sector, energy generation, solar power, wind energy, and small hydro is also there, part of our future. Other than this generation also, 6, we are in mining business, 6 coal blocks already allotted by government, where production is expected very soon, maybe in September 2013 itself, and applied for 6 more blocks. In fact, NTPC has played a very vital role over the years in meeting the generation demand, growing demand of electricity through supply of quality power. In fact, every 4th bulb of our country is lit by NTPC. Other than that also, it was other appreciation is also there for NTPC, continuously been part of the best workplace list in last 9 years. 2013 also, it is 6th best workplace. But I just want to mention that it is the only public sector unit which is appearing in the list, and only organization where employee strength is more than 10,000 megawatt. And I am proud to be part of NTPC. You see that there are other awards also. that in 2011 we were the best IPP, then NDTB leadership in 2013, and third best company in rewards and recognition in 2013. But even after that, we do care for our planet, our environment, and then our people. We are transforming lives of others. We are bridging the gap, that employability, promoting the employability, and bridging skill gaps by adopting existing ITIs, establishing new ITIs, and establishing Power Training Institute. Caring for the planet, whatever ash we are generating, we are trying to consume it. In fact, in financial year 13, 55% of our ash which we have generated, that has been utilized, consumed. And we grow power responsibly. That means in all power plants, continuous emission monitoring system and ambient air quality monitoring system has been installed, and this is first of its kind in our India. In fact, we care for our society, our people more than, first it is people, planet, and power, and in fact, people and planet is before power in NTPC. Now, NTPC, C&I, it has always taken a lead in this country. In 1980s, we adopted DCS-based control system. Offsite control system was PLC-based, and we used to procure it from respective offsite suppliers. But 2005, in order to have uniform hardware control throughout the plant, which has got advantage in inventory management, training, your better maintenance, optimized training and manpower, we conceptualized even offsite control on DCS platform in 2005. Dadri Stage 2 was the first plan where this concept was implemented. That means where all offsite controls are in the same platform as of main plant DCS control. And this has been done in-house. And in Dadri plant onwards, everywhere, we are adopting this philosophy. And in this philosophy, you can operate any control, any system, any offsite system from any position of the plant, any location of the plant, power plant, through, of course, proper authorization. Now, in-house engineering was done for this type of concept, where 40,000 signal typically in a power plant is there. And for entire plant, it is in-house in engineering. We have got unique experience of working with more than 8 international leading DCS suppliers, and topic leadership in international standardization for cybersecurity. Here, it is under formation, and my colleague, Mr. R. Sarangapani, is here. He is representative from India, and he is from NTPC C&I department. DCS recently executed and under execution in NTPC, as you can see from the list, that all leading DCS suppliers are there: ABB, Alstom, BHEL, Emerson, Invensys, Honeywell, Hitachi, Siemens, Toshiba, Yokogawa. So this unique experience, so in this forum, we shall be sharing the collective experience of working with all this system in the following slides. Before we go for this discussion, we would like to mention that this is the situation we all automation suppliers, professionals, we face it, that this is the percentage cost percentage of your automation system, it is very, very less compared to that expectation what we are supposed to. That means impact on everyday operations, safety, availability, optimization, or data analysis, preventive maintenance is very high. This makes our role, automation systems role, people's role, very challenging. Let's see how it is. As you see from the pyramid, okay, is it? I don't know. As you see from this, that over the time, perspective of automation system has grown leaps and bounds. With each advancement of technology, automation engineers have added new functionalities, and layer by layer, these automation systems have reached its present status, that of a full-fledged business tool. I congratulate the automation fraternity on this account. Automation system now, if we go function-wise, the basic things with which it started with, it was the process safety. Now, analysis of the system, how it is, in a challenge to conventional wisdom that increasing safety adds to the cost, new research and evidence reveals the opposite. System function means for protecting, you have to protect the system under all circumstances. You cannot really afford to, in any circumstances, lose the protective or safety system. And for that, analysis of safety functions, including risk analysis, you have to do. Design of safety system based on this design. Failure mode should be predictable, a factor taken into account in design the safety system. Then your system has to be fault tolerant. For ensuring uninterruptible availability of automation system on a single failure, nobody can really accept it, that your one wire is getting open and equipment trips. So this is just not acceptable. And for that, this aspect of engineering is very important, and that has to be done through redundancy, fault-tolerant products, and engineer solution, especially for field-level faults. Process control system actually, it must perform under all process conditions, and for this, nowadays advanced control is available, which previously used to be done only through feed-forward. Model predictive controls have a predictive element in it for reducing deviation and cycling. But important factor is that these controls needs to be customized and tuned to each individual site, which is very, very important. For this purpose, a formal system of determining tuning parameters based on plant design data must be in place. Only fine-tuning should be done at site. For continuous evaluation of such type of tuning parameter, we are providing some softwares in our power plants, for example, auto-tune, triage, etc. But still, you're here that knowledgeable person, knowledge is the key. And for that, DCS supplier must develop a pool of specialized persons for this important area and ensure the successful commissioning of this loop, which is very important milestone in this value chain. Sequence control, we know that it is automation to reduce manual intervention, or it has to be automated to the extent possible, and quick start should be there with limits of material stress that need to be taken care, so as to reduce that human error and enhancing equipment life. Now, automation system plant operation. Now, HMI application should be optimized in such a way that there is no perceptible delay in operation, including the drive level operation. This gives more leverage to the operator for quick decisions. The DCS network also plays a major role in the system response, especially in emergency situations where quick intervention are required. By this, I mean that you should not, when emergency arises, you should not take so much of time in, going from one display to another, and then actually that action, that drive level action you achieve. So it has to be quick enough so as to meet the requirement of the operating that emergency situation. Process monitoring. And here, it is one important area where huge scope of improvement is there, huge scope. Another, it is actually, this is your annunciation. One of my executive director once commented that when I go to power plant, in the TV, that continuous scrolling of message comes. Similarly, in our power plant, continuous some annunciation come. That needs to be reduced. It has to be, information which is actionable, just not the plethora of data you are dumping. So for that, you have to capture that early warning system. For example, slow changing parameter like condenser vacuum. If you can really capture that, and if you can give some early alert to the operator, so operator can take timely action, and he can really add value to the system. So trend alarm is very much required. This type of, if it can be captured, and it need to be. Similarly, alarm you are giving in such a way that operator gets that look and feel of the old days hardwired alarm annunciation system. So we have adopted in LVS, we have given 3-band system where alarms come in 3 different bands. And this is being implemented in all our power plant as a part of DCS, either as a standard feature or as add-on. Another area where, as I told you, that rationalization of alarm is very much required. You have to rationalize it, keeping in your view some standards. For example, ISA standard is there, which gives your around 12 alarms and per point per operator. So you have to design your system taking care of that aspect, and for that, more action is required from EPC contractor or customer, and so that alarm can be rationalized with the given level. Next is your analysis tool. If any trip takes place, whenever planned trips, then it is to be analyzed through whatever your system, whatever your sequence of event or historians is given to the system. Now for that also, this is also very important. Sequence of event, there we have to remember that it is not, absolute timing is not important. Whatever is taking place, it has to be chronologically correct. And hence, as end user, and similarly, historian just dumping of data is not. It has to be engineered such a way that it meets my intended purpose. And as an end user, my requirement is that all this type of analysis tool, whether it is SOE or historian, everything should be available on a single window. We have started specifying some replay feature in our specification. That means which is replay of the plant mimics along with operations performed during the period of interest. Suppose 30 minutes before I want to see this, so it should capture not only mimics, operator actions also. This will be not only give us that analysis part, it will be very much effective learning tool for the operator, that where we have done the mistake. Next is your process optimization. We know that today's regime, when operating cost has got direct bearing on the profitability of the company, and moreover, we are in that PAT regime, perform, achieve, and trade. That regime is there in India. So this has become really very, very important. Moreover, we have to reduce the carbon footprint. So hence, process optimization assumes a great significance in today's business scenario. Advisory systems, which we are giving, that has got some limitations. We have seen in our power plant also such type of systems are given, but implementation of the system, that advisory system, in all station, in all the time, is really not possible. So this type of advanced process control holds the key, which will act directly on your control system and control the, your process. But there we have to remember, this requires huge efforts from the part of the APC supplier during the commissioning in order to instill the confidence among site personnel. And for that, we have to have following these 3 factors, which is really, it will be required prerequisites for success of such systems. These are skill, manpower at automation system supplier end, guidance and cooperation of the equipment supplier, and of course, our site support, management support for this. Automation system diagnostics, which is every automation end user understand that diagnostic is very, very important feature. Sometimes we face such type of problem that some problem has taken place, reply we get that yes, it is not part of, this component is not, it is a network switch problem. So these things should not happen. Whatever it is, whether it is DCS supplier's own product or it is third-party component, if it is there, it has to be, its diagnostic has to be there. It has to be integrated in DCS, keeping in view the end user perspective, that all components should be covered with respect to when the diagnostic is concerned. Early warning of system faults is an expectation from the industry because some fault-tolerant servers have this capability. This can be taken as a food for thought for this industry. Now, whatever automation system we are giving, your special instrumentation, nowadays it is available, like acoustic pyrometer, steam leak detector, your online chloroform measurement, online carbon inas, all this enhance the utility of performance optimization package. Now, this type of instrumentation, especially acoustic pyrometer, really add value to the performance optimization package as it is more accurate and realistic. Now, if we consider really that environmental impact is important, then C&I supplier should make this instrument work aside, not that supply and then our role is over. Hence, as mentioned, the challenge is today that implementation of good boiler instrumentation and, of course, adapt it to the Indian site condition. Now, next is automation system open architecture. We know that we have moved from your proprietary system to the open system. And for that, open architecture has facilitated use of commercially available products like servers, workstations, network switches, routers, and above all, Windows operating system. We are connecting our system to vendor works for remote support. We are transferring our data to enterprise level. So through this, our system has really, we are facilitated to some extent, but it is more automation suppliers they have gained. What we have gained, end user perspective, we have not really gained that much because open system means expectation is interoperability of the plant. That means from one HMI system, I should be able to control other HMI, other system suppliers HMI, which is really not happened. And by that, I mean that suppose there are two systems, system A and system B. From system A, DDCMI, system A, HMI, I should be able to operate my DDCMI system, B control system, which has really not happened. We are trying to do it in our one of the power plant by using the true open protocol, that one HMI. In our other upcoming plant, we are doing that Siemens system, T3000, from operation from Max DNA BHL supply system. It is just, to some extent, giving that operator that feel interoperability, but actually this is not the case. It is only the single HMI in from the operator. Of course, underlying dynamics is not known to the operator. But with that, this type of use of open system has opened up one problem for us, that is cybersecurity. This cybersecurity means that your hacking, your denial of services, virus, worm infiltration, etc. This is really nowadays, it is a challenge for every end user. In fact, if you see that Windows XP, it was launched in 10 years before, but still that patches are coming because vulnerabilities are still being discovered. Cybersecurity, there are three aspects in that. One is your architecture, which is design. Another is policy procedure, how you have to follow, whatever you have to follow, the people aspect. Another is how to enforce it. Now, automation system cybersecurity, for that, our expectation, end user expectation is similar to quality and reliability, security also should be guaranteed by the supplier. Upfront declaration by automation system vendor for security of the system being supplied, especially since components are imported. Incorporate security right in the product design and not as add-on. Vendors to adopt security policies and procedures in their operation and benchmark these security practices against international standards and obtain certificate. In fact, our point is that it is a social responsibility. It should not be seen as a contractual obligation. And it is, of course, collective responsibility. End user is also, should be part of that. Now, next is obsolescence, by which end users are really affected. It is very much correct that all vendors have to keep pace with new technology. Automation supplier adopt new technology after rigorous testing, and existing technology is obsolete, which is inevitable. But if you see that how end user is affected, the total plant life is this much. Then hardware upgradation also comes, new operating system comes, and that new operating system is adopted by end user, your supplier, automation supplier, after vigorous testing. So actual product life, which is available to the end user, is really very small. So for that, automation system supplier has to do, some expectations are there from automation supplier to take care of end user problems. And that is upfront declaration of product life cycle, clear and transparent policy of support, backward compatibility of new products to protect customer investments, and strategies to overcome operating system obsolescence. So for this, your end user has to be made your partner so that they are aware. And to take care of all these problems, we have already adopted something in NTPC, SIL 2 level for your boiler protection system. In-house, as I already told, that in-house development of your all software for logic loop development, interconnection schedule, power plant 40,000 signals, it is in-house software development. And these things has given us not only confidence, it is, again, it will be our flexibility also, because we are not dependent on any software which is commercially available. And other than that, to minimize that, optimize the manpower. Testing we are doing at our application, logic loop testing in our office at laptop, remote testing of DCS, your before factory acceptance test. We remotely also test the software part so as to see that how much readiness of the suppliers. And we have adopted already LED-based LVS 3 years ago, IP-based CCTV 4 years ago. Security system, which was in 2008, which was just as a conceptual aspect in India. It was not that time the terminology how to take cybersecurity things. It was just evolving. NTPC that time adopted the specification. It was thoroughly studied, and those part is already in our part of our specification. Now comes the general concern which all end user faces, that is your quality of field instrument. It is very sorry to share this, that it is quality of field instruments, it is very poor nowadays, and we face this problem very often. And for that, you have to have this type of things. Product quality should be of paramount consideration, benchmark it to international level, site installation, since it plays a very important role. So it has to be taken seriously. Skilled manpower is required for this. System approach needed in site activities, and erection commissioning should be taken very seriously. In fact, these site activities, vendors should consider it as important as manufacturing. This is the expectation from end user. And last part, I want to conclude by that. I know I have taken more than the allotted time. That technology should have value proposition in the business operations. Equipment supplier and automation system should interact closely for getting the best performance out of the automation system, and cyber security aspects to be given importance by the automation system supplier. And last point is the customers should demand solution and not just buy the products. Thank you.